students, welcome to my class. In today's class, we'll discuss how to evaluate given double integrals. Yes. First one, evaluate integral from 0 to 1 and x to root x square plus y square dy into dx. Yes. As in the first introduction class, I have mentioned you how to consider these integrals. So, depending upon these dy and dx, since first we have dy means what? This integral is with respect to y, and dx means this first integral is with respect to x. Yes. So first we'll integrate with respect to y. Let us write this integral as I is equal to, as I mentioned, the first integral are with respect to x. So write the limits as x varies from 0 to 1, and for second integral it is y varies from x to root x. So x square plus y square into dy into dx. Yes. Now keep this integral as it is. X varies from 0 to 1. Now we need to integrate with respect to y. Since we have plus here, x square into dy plus y square into dy. So when you integrate with respect to y, x square acts as a constant. So it is x square, keep it as it is, into dy. Integration of dy is y, plus integration of y square is y cube by 3. Limits varies from y equal to x to root x into dx. Yes. Now substitute upper and lower limits. So what happens? So when you substitute upper and lower limits, x square as it is, in place of y, root x minus x for the first function. 1 by 3 is a constant. Y cube root x whole cube minus x cube, yes, into dx. So now try to simplify them. So now x varies from 0 to 1. So 1. So now x square root x power is 1 by 2. Yes, x square bases are same. So x square plus 1 by 2 is what? X raised to 5 by 2 power. Yes, minus x square into x is x cube, plus root x power is 1 by 2 and into 3. So it will be 1 by 3 into x raised to 3 by 2 minus 1 by 3 into x cube dx. Yes. Now in the next step, here we have x cube and x cube. Try to simplify them. So x is equal to 0 to 1. Keep x raised to 5 by 2 as it is. Yes, plus 1 by 3 into x raised to 3 by 2 as it is. Both have a different power. Now these two have the same power. So 1 by 3 minus x cube minus 1 by 3 x cube will be minus 4 by 3 x cube into dx. Now you can integrate with respect to x now. Yes. So it is when you integrate with respect to x, what happens now? X raised to 5 by 2 integration is x raised to 5 by 2 plus 1. Yes, divided by 5 by 2 plus 1. X raised to n formula. So it is x raised to 7 by 2 whole divided by 7 by 2 plus 1 by 3. Again x raised to 3 by 2 plus 1. So it is 5 by 2 divided by 5 by 2 minus 4 by 3 x raised to 4 divided by 4, limits from x equal to 0 to 1. So now 7 by 2 is in a denominator, 2 by 7 x raised to 7 by 2. You apply upper and lower limits. upper limit is 1. So it is directly we'll apply the limits. So 1 minus 0 plus 5 by 2 is in a denominator, 2 by 5, and already you have 1 by 3. So it is 2 by 15. Again upper and lower limits 1 minus 0. This 4 will get cancelled. So 1 by 3, 1 minus 0. You get 2 by 7 is 2 by 15 minus 1 by. So when you take LCM and simplify, you will get I as 9 divided by 105 or I as 3 divided by 30. This is solution of the given double integral of the function x square plus y square with given limits. Now we'll check one more example. Evaluate integration from 0 to 1 and integration from 0 to root 1 minus y square x cube y dx into dy. So solution, let this be I. So now here you have dx and dy. Means what? Now this integral is with respect to x and these limits, and y means this integral with respect to y now. So now you can write the values as integral y varies from 0 to 1 and here x varies from 0 to root 1 minus y square. This is very much important to write which limits this integral represents. First you have to mention them, dx into dy. Yes. Now, first we need to integrate with respect to x now. So y equal to 0 to 1. When you are integrating with respect to x, y acts as a constant. So y into integration of x cube is x raised to 4 by 4. S limits are varies from 0 to root 1 minus y square into dy. Yes. Now, so when you apply the limits, this y equal to 0 to 1, y by 4 will take 1 by 4 outside, x raised to 4 root 1 minus y square is your x. Yes. Oh, raised to 4 upper limit minus lower limit is 0 into dy. Then 1 by 4 integration from y equal to 0 to 1 y root 1 minus y square whole raised to 4 is what? It will be 1 minus y square whole square. Yes, into dy. So we'll simplify it. It will be easy for our integration. So y, it is 1 minus y square whole square. Apply 1 a minus b square, a minus b whole square formula. Yes. So 1 a square plus b square is y square whole square. Yes, y raised to 4 minus 2ab. So it is 2y square into dy. Yes. Now open the bracket. Right. To make it simply easy by normal your algebra, open the bracket and multiply y. So y into 1 is y plus y raised to 4, y raised to 5, y raised to 5. Yes. Next minus 2 y cube into dy. So what happens now? 1 by 4. Now integrate with respect to y. So y into dy. So it is y square by 2 plus integration of y5 is y6 by 6 minus 2 y raised to 4 by 4. Limits varies from 0 to 1. Simply substitute upper and lower limits for each term. Yes, 1 by 4. Here it is 1 by 2 y square. For y square, upper and lower limits 1 minus 0 plus 1 by 6, take it outside, y raised to 6 again 1 minus 0 minus here 2 and 1 4. Yes, 2 ones are 2 twos. So it is 1 by 2 into 1 minus 0. So what happens? 1 by 4 into 1 by 2 plus 1 by 6 minus 1 by 2. Yes. Now again plus 1 by 2 minus 1 by 2. You get cancelled. So what happens? This is equal to 1 by 4 into 1 by 6. Now we'll move on to next example, that is evaluate integration from minus 2 to plus 2, 0 to root 4 minus x square, 2 minus x into dy dx. Yes. Now let this be I. I put star here because it is important. It's been asked in your model question paper. Simply like this, evaluate. Yes. And also same example is evaluated by changing the order also. So let this be I. Let I is equal to integration minus 2 to 2. Now these are limits of x. Yes, it's a dx means what? It is, these are limits of x and these are limits of y. Y0 to root 1 minus, sorry, 4 minus x square. Function is 2 minus x. Right, write one more time. Hmm. So I equal to integration from minus 2 to plus 2 and y 0 to root 4 minus x square 2 minus x into dy dx. Yes, this is the integral given. Now we need to integrate with respect y first. So x varies from minus 2 to plus 2. Now when you integrate with respect to y, 2 into dy. 2 into dy is 2y minus x into dy is xy. Limits varies from y0 to root 4 minus x square into dx. Yes. Now substitute the upper and lower limits. So x varies from minus 2 to plus 2. When you substitute upper and lower limits, 2 into this one root 4 minus x square is lower limit 0 minus x into root 4 minus x square minus 0 is into dx. So then it is equal to integration from x equal to minus 2 to plus 2. Now function will be 2 root 4 minus x square dx. I will write them separately as minus integral from x equal to minus 2 to plus 2 x into root 4 minus x square dx. Because I have written it separately because it will be easier to us to simplify. So let this be I1 minus I2. So I equal to I1 minus I2. Call this as equation 1. Now we will separately simplify them. So consider first I1. Consider I1 is equal to x equal to minus 2 to plus 2 2 root 4 minus x square into dx. Yes. Now, this is equal to what? Root 4 minus x square. 2 is a constant. Yes. X equal to minus 2 to plus 2 root 4 minus x square. To simplify this, we can use a standard formula of integral, that is, we know that integration of root a square minus x square dx is equal to 1 by 2 x into root a square minus x square plus a square by 2 sine inverse of x by a. We have a standard formula. So now we are going to use this formula to solve root root 4 minus x square in the form of a square minus x square. Means what? A is 2 here. 2 square minus x square form. Directly use that. So 2 into, so when you apply this formula to this integral, so it becomes 1 by 2 x root a square minus x square, x root 4 minus x square plus a square by 2, a square is 4, so 4 by 2 into sine inverse of x by a. So x by a is 2. Yes. Now the limits are x equal to minus 2 plus 2. So take 2 inside the bracket. 2 is related to both the terms. So once you take 2 inside the bracket and put the apply the limits also. Yes. 2 will get cancelled for the first limit, and when you apply first term, when you apply the limits per limit, it is 2, here x is 2 root of 4 minus 2 square, that is 4, is minus lower limit for this minus 2, so it becomes plus 2, square root of 4 minus minus 2 whole square is plus 4, so 4 minus 4 for the first term, first expression, plus again this 2 cancel, so it is 4 into sine inverse of x by a. Sine inverse of 2 by 2 is 1 minus sine inverse of minus 2 by 2 minus 1. Yes. Now, this whole expression first term becomes 0 plus 4 into sine inverse of 1 is what? Sine inverse of 1 is sine 90 is 1. So, sine inverse of 1 is 90. So, it is pi by 2. Sine inverse of minus 1 is minus sine inverse of 1. So, it becomes plus, again plus 4 by 2. So, it is 8 pi by 2, or else you can say I1 as I1 is 4 pi. Is call this as equation. Now consider I2. I2 is what? I2 is integration from x equal to minus 2 to plus 2 x root 4 minus x square is 10 dx. Now for this we are going to use u into v, integration by parts. So we'll consider this as u and this as v. So what happens then? First term as it is u into integration of v. So integration of v is x square by 2 minus double integration of x. So it becomes x cube by 6 into differentiation of first term. So it is minus 2x by 2 root 4 minus x square. Yes. Integration. So it is x equal to minus 2 plus. Now here This 2 and this 2 will get cancelled. So then apply the limits 2 and minus 2. So when you apply the limits, what happens? 1 by 2 is a constant for the first term. Root 4 minus x square. Root 4 minus 4 into x square by 2. 4 by 2 minus lower limit for this. Root 4 minus 2 whole square is root 4 minus 4 into again root 2 square minus 2 square is again 4 by 2. Yes, this is for first. Minus for the second one, it is 2 cube 8 by 6. This 2 get cancelled into minus 2 divided by root 4 minus 4 upper limit minus lower limit. Lower limit is minus 8 by 6 into minus 2 by root 4 minus 4. Yes. What happened? Since we have root 4 minus 4, 4 minus 4, whole expression becomes 0. All this as 0. So now substitute 2 and 3 in 1. We get what happens? I is equal to I1 is 4 pi, I2 is 0. Therefore, I1 is 4. Whenever you ask to evaluate, you have to evaluate. Simply perform like this. If you are asked to evaluate this by changing the order, we'll see in the next part. But from both the methods, answer will be same. You are getting same answer, right? 4 pi only. Yes. In the next class, we'll solve examples of triple integrals. Some examples on triple integrals. After that, we'll move on to how to solve the double and triple integration by changing its order and by changing the variables to polar coordinates. Yes. Till then, keep practicing the examples. If you have any doubts, you can comment in the comment box. If you are not yet subscribed my channel, please do support and subscribe my channel. Till then, take care. Thank you.